Okay, we are at Hack Day 2025 in San Francisco. And we're about to do a workshop on building production-ready AI agents with Strands agents. In this workshop, we're gonna do three things. First, we're gonna build our first agent with Strands agents. Then from there, we're gonna talk about how easy it is to use different model providers within Strands agents. And then after that, we're gonna use custom tools, built-in tools, and MCP servers inside of Strands agents. Okay, we're gonna talk about building production-ready AI agents with Strands agents. I'm gonna do a quick presentation, then we're gonna dive into some code so you can actually see how this works. Now, my name is Lightfoot. I'm a developer advocate at AWS. Myself, Lord, and Ellie are all here to help you build production-ready AI agents at this hackathon. Now, I'm gonna start this off setting the tone on what is agentic AI. At AWS, we define agentic AI as AI agents that are autonomous systems that can understand, plan, and execute actions to achieve specific goals. So if you communicate with a traditional LLM, it can't do things like look at the weather. It can't do things like look up the time. It doesn't have access to tools or its environment. It also is not gonna remember your name when you open up a new session. So when we started talking about agentic AI, we're building those building blocks along with observability so we actually can see how the agent thinks and allow the agent's reasoning capabilities to make intelligent decisions on how to solve our problems. So when we talk about from Strands, Strands is an open source SDK. So if you all want to contribute, you can contribute to Strands agents. It supports MCP and A2A, and you can get started in a few lines of code. So if you look at this example, in 3 lines of code, I am already invoking my first agent. Now, if we go under the hood, Strands has something called an agentic loop. There's 3 things to make an agent within Strands. You have a model, you have tools, and you have a prompt. We allow the reasoning capabilities of a model to really shine. The models are getting smarter, they're getting more intelligent. They are able to make decisions on when to make a tool call, on what tool call to make, how to create a plan, and how to achieve the actions in that plan. So if we look at Strands, I mentioned that it's model agnostic earlier, meaning that it supports models in Amazon Bedrock. It also supports models on Anthropic, models through Light LLM, Olama, if you want to build and run agents locally, as well as OpenAI, and you have the ability to build your own custom providers within Strands agents. There are many pre-built tools within Strands. So things like look up the current date and time, and many other HTTP request tools, and many other tools are available in Strands, and I'll show you how you can take a look at those. Now, it also supports MCP. For those of you that are building MCP servers today, I think you'll appreciate how simple it is to get started with MCP servers. Now, if you scan this QR code, you can take a look at some resources that will help you with today's building Strands agents inside of the hackathon. All right, I'm actually going to go to strandsagents.com so you all can take a look on how we do this. So let me stop my presentation. So we'll stop that and we'll go to strandsagents.com. So when we go to strandsagents.com, you're going to see a user guide, you'll see examples and API reference. If you go to the user guide, here's where you'll find out information about the different components within Strands. So you'll find things about the agent, the agentic loop. It handles session management, conversation management. As we know, when we're communicating with our agents, the contact windows grow very large. So you may have to do some sliding window to remove some of the conversation from the conversation management. as well as you may want to remove summarize the conversations within the conversation manager. You can do that as well, and you can create your own custom conversation managers within Strands. Now, if you want to find out information about the tools, here are everything you need to know about the community built-in tools within Strands. And we'll walk through some code here in a moment. But these are all the built-in tools that you can use right now with a single line of code. I mentioned the model providers, and then information on how you can build some multi-agent solutions within Strands agents. If you're looking for some ideas during the hackathon, there are some examples on strandsagents.com. And finally, if you really want to dive into the event loop and actually the components of Strands agents, you can look at the API reference. Now, the QR code that you scan will take you to this CloudFront. On this CloudFront, there's a survey here. If you fill out this survey, you get $25 in AWS credits. So be sure to fill out the survey, get your credits. We would love your feedback. There's also information on different resources for Strands agents. So if you want to know how to build with Strands in a workshop, there's a workshop that you can use, spin up in your own account. There's also sample code on GitHub for using Strands, the Strands agents documentation, and Ellie and Laura, who's here today, they develop a course on getting started with your first Strands agents. This course will help you really dive into building agents. Be sure to check that out. And then the slides that I presented, all of that is on the CloudFront. Now let's dive into some code. Now, all of this code that I'm showing is in the sample. I'm going to go through this because some of you may not be familiar with Strands. This code will have these Jupyter notebooks along with sample code where you can spin it up right in Python. But when you first get started with Strands, we're going to load up our environmental variables. The pip install that you need, we're going to do Strands agents and Strands agents tools. And then we also have to install the Strands agents models that we need. So Strands agents. And then we would have to do OpenAI and Anthropic. OpenAI, but I already had these installed, but it's just as simple as this to get started with different providers. Now in these examples, I am going to use Anthropic. So the first thing we'll do is import Strands, and then we'll use the Anthropic model. In the Anthropic model, we'll pass in our API key, the tokens that we need, and then we'll set the temperature, and then we'll invoke our first agent. Notice here that we pass in the model and the system prompt. And then we're going to invoke our first agent with something simple like tell me a joke. And so now we invoked our first agent and it tells us a joke. Great. Now let's actually look at Strands to check a few things out. The first thing we're going to do is look at the response. So when we get a response from Strands, there's a few things that you'll see. You'll see the message, you'll see the metrics, you'll see the state, and the stop reason. If you are building agents, or if you're writing code, leveraging LLMs, and they're using tools, you're going to need to know the stop reasons so you can figure out what actions to take. And so here, if we look at the message, this is going to be the most recent message from our assistants. And you can see that here. Now, if we're trying to understand and evaluate our agents, Strands has built-in metrics. And so now I can look at this event loop. And to make this work better, I'm going to import Pretty Print so we can actually see this better. And so now we'll do our response.metrics, and we'll Pretty Print that. And so as you can see, we can see inside of that event loop how many times it took, how many turns it took to get the agent to solve our question. And here you see it was one cycle. It shows the cycle duration, the tracing, if you're trying to really get that OTel data and really understand your agents to trace. You can see that here. And then you can see your accumulated token usage. So if you're really trying to cost optimize, all of that is built within Strands. Now, the next example we're going to look at is we're going to create a simple agent that has a couple things. First, we're going to give it the tool of calculator, and then we'll create a custom weather tool. And if you notice that from Strands, we import our agent, and then we import tool. This allows us to use a custom decorator on top of a Python function to make it a tool within Strands. So if we take a look at this, we create a function that says get weather. It doesn't have any inputs, it's just a simple get weather. And we can actually modify this to make it simpler. So let's just say city. So we'll pass in the city, and it's a string. And so here, we'll say the weather in city is sunny. And so now, when we ask the assistant, what is the weather today in San Francisco? And we invoke our agent, you'll see it uses the weather tool. The weather today in San Francisco is sunny. As you can see how easy it was to create a tool and then pass it into our agent directly. We didn't have to worry about the JSON schema. All of this was handled by our agent because of the built-in tool decorator. Now, another thing that I want to talk about is Strands has something called hooks. In this event loop, if we come back to the Strands documentation and we go over to our agent, it has something called event loop. There's a couple ways that you can actually log or take actions during this event loop. And so if I come in here and look at hooks, I'll show you exactly what I mean. So we go into our agents and we look at hooks. So there are different invocation points inside of Strands. So you have a request start when you first invoke the agent. You have model events before it actually invoked the model. You have tool events before those tool calls, and then you have request events. So at any point or any event point within the agent event loop, you can take some action. Maybe you want to verify that a tool was called. Maybe you want to modify the system prompt. Maybe you want to perform some other action. Using event hooks within Strands will allow you to do that. And so I say that as we go back to our example, one thing that you may want to do is actually ensure the right tool was called when that agentic loop happens. You can do that with Strands, and if the right tool wasn't called, you can actually modify the tool call before the results actually go to the agent. And so right here, we're going to directly invoke our tool, and notice that we directly invoked the tool, and here's the result. And so this tool result, if we directly invoke the tool, we can actually change it and send it to the agent using event hooks. Now, looking at logging within Strands, this is pretty simple to do as well. So first, we have a logger, and we're just going to start the logger as we invoke this agent. And let me make sure I change the model so it uses the right model. So we'll come in here, and we'll change the model to use Anthropic model, and we'll just say hello. So if you're logging the Strands agent, you can see a lot of things. And I am inside of a Jupyter notebook, but one of the things I can see is that the right model was called, right? I can see the tokens and configuration for the model. I can see the prompt that was sent, and I was also see the response. I can also see the conversation manager that's configured. If you remember that I mentioned the conversation manager that is built in Strands, by default is set to sliding window conversation manager, meaning that you can have 40 conversations within an agent before those conversations start being removed. So if I communicate with an agent, invoke an agent, I get a response, the tool calls, the tool results, all of that goes in the context and will have to be managed within your agent. Strands does that for you. Let's actually take a look at that. So if we look at our agent, we can do a few things here. So if we go to agent.model.config, we can actually see what model is configured. And again, as we invoke our agent in our code, we can easily modify the model that's being used either within the code or using an event hook. And I've already kind of talked about model providers, so let's actually take a look at using a local model with Ollama. So in this example, I'm going to show you how to build a local agent using Ollama. We'll use a Llama model and run it right here on my laptop. So we're not invoking any external APIs. So I'll ensure that we have all our requirements. I'm using UV. So I'll install the Strands Agents Ollama model provider. And then from here, I'm going to import OS, import requests, import our agent, our tool decorator, so we can actually create a tool, and then we'll import the Ollama model. Now, we want to ensure that Ollama is running on our local laptop. As you can see, localhost, API tags, and we're going to verify that Ollama is actually running. We're also going to verify our model that is running. So notice this is our list of models, and this is the model we'll be using for this workshop. Now, one thing I want to call out is that since we're using Ollama, all of these models are open, and we can download these models on our local laptop. So depending on the, I would say, capacity of your hard drive space, your RAM, your video card, you can actually create some pretty powerful local models on your systems. So the next thing we're going to do is define some tools. So we're going to define a file read tool, so we can read a file. We're going to define a write file tool, and then we'll define a list directory tool. So we'll define these tools, and now our tools have been defined. The next thing we're going to do is create a comprehensive system prompt. And in this system prompt, we're telling the agent to modify its behavior. We're telling it that you are a helpful personal assistant capable of performing local file actions and simple tasks for the user. Here are your capabilities. When using the tools, always verify the file paths before operations, be careful with system commands, and provide clear explanations of what you're doing. If a task cannot be completed, explain why and suggest alternatives. Always be helpful, concise, and focus on addressing the user's efficiency. Now, we'll define the model ID along with our system prompt, and then from here, we're actually going to define the model provider that we'll be using. Here we define the Ollama model provider, the model ID, the host, and then all of the params that we'll use for that model. After that, we'll create our agent with our system prompt, the model, and the tools we'll use for this demo. And now everything is created. The next thing we're going to do, we're actually going to invoke our agent. And now, we're telling the agent to read the file path for our sample file. Here's the file, and summarize it in 5 bullet points. Let's make sure the file is there. Here's the sample file, and we want the agent to summarize this file. And this is all going to be done locally on my laptop. So we'll run our local agent. JSON loads, we have an issue. Let's make sure I ran everything needed for this demo. So if we come back up, make sure I got everything running. Did we run that? Yes. Do we need JSON? Let's see. Import JSON. All right, so that's running. Our file is running. System prompt is good. That's good. Now let's invoke again. Model, okay, so it's saying my model's now found. Let's pull down this model and make sure we have the right model. So if we come back up and look at our models that are available, I got 3B. So let's change the model to ensure we have the right model configured. I didn't want to download a new model because of bandwidth in this environment. So we'll change the model and then we'll run our code again. We'll configure our agent with the new model so the agent knows. And now we'll invoke our agent again. And let's see what happens this time. Our local agent. Let me clear all outputs. Let's try this one more time. All right, so let's make sure all that's good, all the requirements. We're good. We're good. All right. Okay, we have that. We'll change that to tools. We'll make sure everything's good with that. We'll create our tool, system prompt, and we may have to do some troubleshooting. Let's make sure this is running. We're good, and one more time. Okay, it's working now. I didn't have all the dependencies installed. And so now we can look. We have the first tool called file read. I apologize for an issue. It seems there is an encoding problem with the PDF. So it can't read the PDF. So what we need to do is give it another tool. Oh, okay. Now it's able to see the tool. It sees the tool, it was able to extract the information from the file, and then it was able to summarize it. Okay. So at first it couldn't figure out the issue. It figured out the issue, and then it was able to summarize the document. So our agent was able to figure it out, and all of this was local. So the agent really was pretty capable to be a local, smaller, 3 billion parameter model. Now I wanted to list my files in my directory, and it's listing all of my files in this directory. And this is all my local agent. Now I wanted to create a file. We're just verifying that all the tools are working. So if we come in here to sample file, we should see sample file here. So our local agent was able to run locally to read a file and summarize it, to read the files in our directory and list them, and then from there it was able to write to that directory. Open source SDK using a local model. So there's a lot of freedom and capabilities that you can do locally without access to any external model providers using Strands agents. Now the next thing I want to do is actually come in here and use MCP. So we're going to use different tools and MCP using Strands agents. If you come back to the documentation, I always like to go back there because this has everything we need. If we go to Tools Overview, this will tell you everything about using tools within Strands. All of the built-in tools, the ability to create custom tools, as well as MCP. Strands even has a feature to hot load tools. And if we have time, I'll show you that. But what I mean by hot load tools, a Strands agent could actually write Python code, creating its own tool, and then using it in the same runtime. So it's pretty powerful. Let's come back over here and take a look at the code. Notice here we have our AWS documentation assistant agent. We're going to leverage Anthropic rather than Amazon Bedrock, just so we ensure that everyone has access. Now from here, we'll load our environmental variables, load up the right environment. So we have that all loaded. Our requirements should be good to go. And then from here, we have our Anthropic model imported. Let's install all of our requirements into this environment. So we'll install that because we don't have those. And we'll make sure everything is loaded into this virtual environment so we can use it in this demo. So we're gonna go through this And once we go through this, I'm gonna go back through my demo that I did earlier because I got a lot of questions about it, and we'll kind of walk through how I built that and answer some of those questions. So we're waiting on our dependencies, and looks like all of our dependencies are good to go. We'll load up our environmental variables again. Then from there, we'll import all of our, Strands agents, models, Anthropic model. Okay, so we'll have to go back up here and install our Anthropic model. So we'll do UV add and Strands agents. And it's going to be agents, and it's going to be Anthropic. And we'll also do OpenAI just in case. And Olama. So we'll just add all of those. Require arguments. There we go. And now they're all added. We'll load our environmental variables again, and then our Anthropic model should work this time. From models.anthropic. There we go. All right, so we have our models loaded with Anthropic, so we can use that. MCP is loaded, our agent is loaded. All of that's good, everything's imported. The next thing we need to do is create our Anthropic model. So we'll create our Anthropic model. And now, what we need to do is actually connect to the MCP server using an MCP client. And this is going to be standard in, standard out. AWS, if we go to AWS Lab documentation, so we go to AWS Labs, MCP. On the AWS Labs MCP GitHub, there are a ton of AWS supported locally run MCP servers. So you can use these MCP servers to get documentation via MCP, connect to your AWS resources via MCP, and run those in your environment. So here we're going to get the AWS documentation. We created a client for that. And now what we're going to do is we're going to ask the agent a simple question based on the documentation. And the question is going to be, what is Amazon Bedrock's pricing model? Be concise. And so we'll see this start the MCP server, list the tools, and then the agent will be invoked with our prompt and make the tool call. And so as you can see, here's our search the documentation. Here's the read documentation, and then the model response. And that was pretty quick. All of this was done via MCP. So we built our first agent, we made tool calls, we created custom tools, and we leveraged MCP with Strands agents. I'm gonna go back to my code that I ran earlier. And let's actually do that. So if we come in here, I'm gonna pull up my terminal. We'll go to documentation, temp, and hack SF. Then we're gonna code that. All right, so we're already in here. And I'm just gonna walk through this demo code one more time because I got a lot of questions about it. So earlier I did a demo using two MCP servers that I built. And all of these are available on my GitHub. So the MCP servers are a GTP thumbnail MCP server and a YouTube API project MCP server. The goal of these MCP servers is to be able to generate thumbnails via OpenAI and get metadata and transcripts from YouTube. I use Strands agents to connect to OpenAI and the MCP servers. I have a file write tool, a file read tool, an editor tool, and a shell tool. So this agent has all the capabilities it needs to write a blog post based on the transcript. I load my environmental variables. I set the bypass consent to true because if I'm building an autonomous agent, I need it to be able to freely run in an isolated environment to perform a task, troubleshoot the task, and be able to solve the problem. Now I'm using the OpenAI model provider. And now I'm building my YouTube MCP server client, and then my GPT MCP server client. I have a prompt that's been optimized to work for this agent. And then from there, I give it a prompt to write a blog post based on this video. I'm gonna give it a new video this time, and then we'll run this one more time, and then we'll complete our presentation. So we'll go to my YouTube channel, Lab Every Day, and we'll just pull up a video. We'll try to get a shorter video, and let's see. We'll do how I pass the AWS Solutions Architect video. So we'll take that, and we'll just copy in this prompt. We'll pull up our terminal. We'll give it a minute. And so while our terminal is open, we have this with statement here in order to open our MCP clients, grab the tools for each one of those clients, and then we actually print them out so we know which tools are available. And then we actually create our agent, our blog agent, and then we invoke our agent with a prompt. So if I come here to our terminal, got a new terminal because that terminal is not open. And we can just run it from here. Source, BNB, bin, activate. We are now in our virtual environment. And so now if I do Python demo, .py, and we run the code, we can actually see all these tool calls. And so as you can see, we are starting our MCP server. We are listing the tools that are available. We're getting the transcript from YouTube. Tool 1, and Strands is logging all of this real time. Then from there, we are generating an image from OpenAI. We'll close that out, and we'll just open this up. And then we should see a new blog post and a new image here shortly. All right, so we're waiting on the image to be generated. There's the image, it's been generated via OpenAI. Now we're running share commands because when this downloads, it downloads to a temp environment, and what we want to do is move it into our current directory so we can actually add it to the blog post. This code that you're looking at, I actually use this on my own blog, and I have it fully autonomous. So if I created a new YouTube video, it will automatically upload to a temporary blog site so I can read the blog, see if it makes sense, edit it in my own words, and then I can move it to my actual blog. So if we come back over here, we should see this new AWS certification blog. It should have an image. Master AWS certification, a journey through exam preparation. The image was generated. Here's the blog post based on the video. And then the video is embedded at the bottom, so we should be able to open the video. And this takes us to the video. And so in a few lines of code, we were able to do multiple things within Strands agents. If you all would like more information, feel free to check out the resources that we have available. Ellie, Laura, and myself will be here to help you, guide you through any other challenges you have with Strands agents. If you just want to talk agents and agentic AI, feel free to grab us. We love talking about this and building agents. We'll be here. So thank you all again for tuning in. Thank you, Adam, for having us. And thank you to the whole entire hackathon for this opportunity to present. Thank you.